Am I audible, guys?
Yes, sir.
All right. Just give me 1 minute. I'll turn on the other lights. All right. So, students, today is our fourth lecture. Fourth lecture on the subject of science and technology. And please excuse me, I have a little bad throat today, but I'll be able to manage easily. It will not be such a problem. And now, when you talk about the subject of nuclear energy, we have started with the topic of nuclear technology. I had told you about the various forces of nature. Then I told you about strong nuclear force, weak nuclear force. We had a discussion on both the topics. Under weak nuclear force, I told you how the radioactive carbon dating works, how what is radioactivity. We talked about all the radioactive elements in nature, right? And then after that, we moved on to the discussion of India's nuclear energy program. And in the discussion of India's nuclear energy program, I told you the relevance of the program, right? Why the three stages are there. And secondly, I also told you that why or what India has planned to reach, right? Like India has planned to reach thorium based energy, because that is the only way which can make India a truly self reliant country in terms of energy production. So India has planned to create or to acquire moderator based reactor and breeding technology, right, in order to make the thorium based reactor a success. Then the third part, then after that, we have talked about the various methods through which nuclear reactions may be created or maybe conducted. One is called nuclear fission and the other one is called nuclear fusion. While discussion of nuclear fission, I explained the meaning of controlled and uncontrolled nuclear reaction. A controlled nuclear reaction is what happens in a nuclear power plant where the energy output of a nuclear reaction can be controlled. And if you remember how we can control it, just control the trigger condition. Just by controlling the trigger condition. So if we can control the trigger condition, we can obviously control the energy output. Similarly, when you talk about an uncontrolled nuclear reaction, an uncontrolled nuclear reaction occurs in a nuclear weapon system, and India has also successfully demonstrated that. And this is where we do not control the trigger condition, we let the neutron hit multiple uraniums at the same time, and we want the reaction to become uncontrollable, right? That is the simple concept of nuclear fission. Now, guys, if you have any questions to ask, please ask. If you have any questions to ask, please ask, students. Any questions to ask? Acha, by the way, all of you, I believe, are able to understand the things, right? Shritama, you're from non-science background. Are you able to understand? Otherwise, all right, perfect. I think you were not there in the last class, so please make sure that you are following the recordings. And see, guys, Manjunath sir, the founder of PMFI and IS, he has also texted a message to all of you that please please consider it as a condition that you have to attend the classes live, because there are two reasons for it. I'm telling you from the perspective of a faculty only, from a teacher's perspective. See, when there are two students taking live classes, you feel more engaged. As a teacher, I'm saying, of course you guys will also be feeling more engaged, but you feel more engaged as a teacher, and you can obviously respond to the comments at the same time. You can obviously interact with students, like I keep asking to write yes, yes, right? So these are ways through which it can help me also as a teacher, and I would be able to know that to what extent I can go, right? There are moments when I have recorded videos for students to watch them later, but it has happened sometimes that when I make those videos and by the time the recording gets uploaded, I realize that I could have added one more point, right? So like this happens, but when you are taking the class live, these kind of things usually don't happen, right? So we are always more committed, we are always more connected to the students when you take the classes live. Okay, so this is my also request to all of you, that you make sure that you attend live classes. Okay, otherwise you have the access of the classes till 1st of January 2027, right? You have it for more than 1 year, so that should not be an issue as such. All right, so let us start. So guys, now I'm going to talk about nuclear fusion. Now we'll start the discussion on the topic of nuclear fusion. Now what exactly is nuclear fusion? So I have told you in brief, fission means to break, to separate, it is still written there on the screen, and fusion means to assimilate, to merge, to join, right? So when you talk about nuclear fission or fusion, nuclear fission means splitting of a large nucleus into smaller nuclei, whereas nuclear fusion means combination of smaller nuclei into one big nucleus, right? Combination of smaller nuclei into one big nucleus, we call it nuclear fusion. Got it? Now the point is, how does this nuclear fusion occurs? So guys, this is the reaction of nuclear fusion, right? You can see in this reaction we have deuterium. You can see H2 is deuterium, all of you guys can recall, and it is being merged with H3, that is tritium, and they both are merging together and creating helium. You can see helium having higher atomic number, higher mass number, plus one more neutron is being produced, plus one more neutron is being generated, right? So you can see deuterium plus tritium is producing helium. This is what is exactly happening in the case of nuclear fusion reaction. In the nuclear fusion reaction, this is happening. But guys, let me ask you quickly, what was the trigger condition of nuclear fission? Nuclear fission, what was the trigger condition, guys? Quickly tell me. High speed neutron. Very good. High speed neutron was the trigger condition is nuclear fission. So nuclear fission trigger condition is high speed neutron. But in nuclear fusion, the trigger condition is different. Just give me 1 minute, guys. Let me have some medicine for my throat at the same time. All right. So in the case of nuclear fission, the trigger condition was high speed neutron. High speed neutron was the trigger condition, right? This high speed neutron started the nuclear fission reaction. But now let us start the trigger condition for nuclear fusion, and I want all of you to pay 100% attention here. Okay, nuclear fusion, what is the trigger condition? So guys, the idea is, I want you guys to pay 100% attention here. You have to concentrate a lot right now. Okay, it is just a visualization of the next 10 minutes and the things will be very clear. So guys, in nuclear fission, we made the high speed neutron hit uranium nucleus, and uranium nucleus got split into krypton, barium, a lot of energy, and 3 more neutrons, and that's how the chain reaction also started. Now when we talk about nuclear fusion, to understand the trigger condition of nuclear fusion, where two smaller nuclei are fusing, are merging into each other and creating one large nucleus, please pay attention. So guys, let's imagine, I want you guys to simply imagine, let's say there is a complete empty space. Let's imagine that there is a complete empty space, and when I say complete empty space, that means there is nothing, not even a single molecule, not even a single atom, complete empty space. And now imagine if I go to this empty space and I put one deuterium, I go and put one deuterium atom. What is this deuterium atom? Just two particles inside the nucleus, proton and neutron, and one electron revolving outside the nucleus. All of you would agree, right? Just one proton, just one deuterium. Now, of course, this deuterium is just a small particle, guys, just one proton, one neutron, and one electron, a very small particle. Then let's suppose I go again and I go and put one more deuterium. I've put two deuteriums now. Now, guys, both these deuteriums are small particles, very small mass. But don't you think, guys, even though they have small mass, even though they have got a small mass, but don't you think still, even with this small mass, they should have some small gravity of their own? Don't you think so? They will have some gravity, because what is gravity? Gravity is nothing but the manifestation of mass only, right? So even though these particles are small, but they will still have a little bit of gravity of their own. They both will still have a very little gravity. Okay, they will have a little gravity of their own. Now, because of this gravitational force, gravity is an attractive force. What will happen? Both these particles will start moving towards each other, right? Because gravity is an attractive force. Both the particles will start moving towards each other, and as they start traveling towards each other, because both of them have same mass as well, they both will start traveling towards each other, and slowly they will start mutually revolving around each other, right? This, because they both are pulling each other with the same force, they both are going to pull each other with the same force. So we will notice that both of them will start coming closer and closer, and then they will start revolving around each other like this. Tell me yes in the chat if you guys are able to visualize. Tell me yes in the chat if you guys are able to visualize. So they both will start mutually revolving around each other as they both start pulling. Okay. So we have two particles of deuterium revolving around each other independently in space. This is likely to happen in space when it is complete empty space. Now, guys, you go there again, and this time you carry a bunch of deuterium and tritium. So what you see, you pick up one tritium or you pick up one deuterium, you throw one deuterium in this particular space. What will happen? Two deuteriums are already mutually revolving around each other like this. The moment when you throw one deuterium more, the third deuterium will also join, and now there would be three deuteriums. Now there would be three deuteriums revolving around each other. You will throw one deuterium, three deuteriums will start revolving like this, right? And you do one thing, you keep throwing one deuterium after the other, one tritium, one deuterium, one helium. You keep throwing these particles one after the other. Of course, helium is a little heavy, tritium is little heavy, but still they will all keep joining this group, and they all will start mutually revolving around each other like this. They all would start revolving like this. I hope all of you guys are able to visualize. So when you keep throwing these particles one after the other, when you keep throwing these particles one after the other, you will notice that all these particles will start mutually revolving like this, one after the other. They will all start revolving like this, in this manner. So very simple to visualize, right? It's quite simple to visualize that all these particles will start revolving like this with each other. Got it? So this is what is going to happen when you have these bunch of particles in the complete empty space revolving around each other, having similar mass, similar gravity. Now, guys, let's imagine if I go next, and this time I take a billion of these particles, billions of deuterium, and I throw a billion of deuterium particles in this space. Then I take a billion of tritium and I throw a billion of tritium in this space. Then I take a billion of helium and I throw a billion of helium particles in this space. What I'm doing, I'm basically throwing billions and billions of these particles. And now, guys, earlier there were hardly few hundred particles. They were simply revolving around each other. So earlier there was nothing but a group of few particles. But now I have added billions and billions of deuterium, tritium and helium. And now with billions of particles, it has taken a shape of a cloud. A cloud of deuterium, tritium and helium. A cloud. And the cloud is having billions and billions of particles, maybe trillions of particles. And now, don't you think all particles, single particles still have the same mass? They all will be attracting each other with the same mass, with the same force. But now there are billions of such particles attracting. Just think about it. Earlier, there were two deuteriums. They were attracting each other. right? Earlier, two deuteriums were attracting each other. Got it? But now there are billions of deuterium. There are billions of such deuterium, tritium, helium. Don't you think all of them would start attracting each other? Right? All of them would start attracting each other. Don't you think so? All of them would start attracting. And when all of them would start attracting each other, all of them would start attracting each other. So what will happen? What will happen? Just think about it, guys. Just think about it. Earlier, there were few particles that were simply revolving like this. But as I kept on throwing new matter, as I kept on throwing new mass of deuterium, tritium and helium, what happened? All these single particles, they kept on coming closer and closer to each other. And I hope you understand why. Because the overall mass of the cloud has increased, and because of this overall mass of the cloud, the entire matter is now going to come closer and closer. So earlier, these particles must have been revolving like this. But because of now greater mass of deuterium, tritium and helium, the particles may be revolving like this. Can you see what has happened? Shritama, can you visualize what has happened here? So basically what was the case? Earlier we had just few particles. These few particles had some small gravity of their own, and because of that they were revolving like this. But the moment when we added billions and billions of these particles in the same space, now the overall mass of the cloud is so heavy that now all these particles are attracting each other. Everyone is pulling each other, and now the gases would be revolving like this. Right? They have got closer, and the closeness is mainly because the entire mass of the cloud has got heavier. The mass of the cloud has got bigger, it has got heavier, and because of that it now has a much stronger mutual force of attraction. I believe all of you guys have to visualize, but the story isn't over yet. So let's suppose you throw some more matter after this. So we had already put billions of deuterium, tritium and helium, but now let's suppose I pick up another billion of tritium and I throw another billion of tritium at it. I take another billion of deuterium, throw another billion. When I keep doing that, the entire cloud keeps getting heavier and heavier. The entire cloud keeps getting heavier, and all the particles keeps getting closer and closer, closer and closer, until, so earlier they were revolving like this, then they started revolving like this. But if I keep increasing its mass, the mutual gravitational force will keep increasing, and don't you think they will start revolving like this? What is happening, guys, between my hands? What is really happening in between my hands? Are they able to freely revolve now? Are they able to freely revolve? No, there is a lot of friction now happening between particles. And what happens when there is friction? Tell me, guys, what really occurs when there is high friction? Tell me, what will this friction lead to? If I start rubbing my hands like this, what it will create? Quickly. Heat. Very good. Vani, it will create heat. Shritama, I hope you are able to visualize. So basically, I'm reiterating the entire thing. So earlier, we had deuterium, tritium and all these particles revolving like this. But when we kept on increasing the matter, when we kept on increasing the mass, they kept on coming closer and closer. They kept on coming closer and closer, and they started revolving like this. But as we kept on increasing the mass even beyond this, they started coming even closer, and they literally started rubbing around each other. They literally started rubbing around each other, and this rubbing would create friction, and that friction would essentially increase the temperature of this entire cloud. The temperature of this entire cloud would get heated up because all these particles are now literally rubbing around each other. So guys, what is really happening? Just visualize. Because of higher mass, the gravitational force between the particles of the cloud will keep increasing. And guys, this gravitational force is attractive in nature, so all the particles will start attracting each other. Guys, can I say this gravitational force would literally be acting as if there is a pressure being applied from all the sides in the cloud, as if there is some pressure being applied from all sides of the cloud. And can I call this pressure like there is some pressure being applied from all sides of the cloud? So let's suppose if there is a higher gravity, all these particles will literally be coming closer and closer to each other. And guys, can I call this entire pressure as gravitational pressure? Guys, what is pressure, by the way? Don't worry about pressure and force. Why am I using pressure and force differently? Actually, pressure is nothing but when a force is applied on an area. So when a force is applied on a certain area, we use the word pressure for it. Like for example, let me take something to explain it better. Yeah, so look at this. Okay, I'll take this ink pen. So look at this. So I've got this pen with me here, right? You can see the edge of the pen. If I start poking my finger, if I start poking my hand with this edge, I may feel that there is some pressure being applied, there is some force being applied, but I would not get injured from this force, right? Even if I slightly increases, I won't get injured. But imagine if I open this particular pen, and now you can see a very tiny, a very thin needle, and now when I start poking with this needle, of course it's going to hurt, right? Of course it's going to hurt. The same effort if I apply, compared to the previous edge, if I apply the same effort in this case, it may even pierce into my hand. I hope you can understand. So what is pressure, guys? Why am I using pressure in suddenly in place of force? Because pressure is nothing but force applied on an area. So when you apply force on a certain area, we call it pressure. I hope you are able to get it right. So force is usually applied on a direction, and force applied on an area is called pressure. So because all the particles have literally started pulling each other, we'll say that there is a high gravitational pressure. There is a high gravitational pressure that is created because all these particles have literally started pulling each other. Got it? And because of this high gravitational pressure, they kept coming closer and closer. They kept on coming closer and closer, and until they reach so close that they literally start rubbing around each other. These particles, they may be this far. These particles may be this far earlier, but as we kept on increasing the mass, the gravitational pressure kept on increasing. They kept on coming closer and closer, and now they are literally touching each other. And as they touch each other, there is a lot of friction that gets created, and this friction eventually increases the temperature of the cloud. It essentially increases the temperature of the cloud. And guys, you'll be surprised to know to what extent the temperature gets increased. The temperature of the cloud increases. The temperature gets increased up to 6,000 Kelvin. The temperature gets increased up to 6,000 Kelvin. Now you may ask, what is Kelvin? Kelvin actually is the standard unit of temperature. It is not degree Celsius, it is not degree Fahrenheit. Kelvin is the standard unit, right? And it's a very simple concept. You'll all be able to understand it in one go. If I just write down 0 degrees Celsius, 0 degrees Celsius is simply equal to 273 Kelvin. 0 degrees Celsius is equal to 273 Kelvin. That's a simple relationship between Kelvin and degree Celsius. Yesterday itself, I tell you, don't again think about so many SI units, right? Don't think about SI units. Don't think about multiple units of the same physical quantity. They have different units are available. Like for distance, we have centimeter, we have millimeter, we have meters, kilometers, miles. All these are units of distance. But I hope you understand they all were created because of the inconsistencies in the sharing of data, inconsistencies in sitting together and coming up with some standardized formats. So every country had their own units. It is just that today we are struggling to create conversion factors for all these units. So similarly, somebody had Kelvin, somebody had degree Celsius. So we had to now study both of them. Okay. So degree Celsius, 0 degrees Celsius is equal to 273 Kelvin. If I want to know what is 10 degrees Celsius, if I want to know what is positive 10 degrees Celsius in Kelvin, you just have to add 10 to 273. You get 283, and it is 283 Kelvin. As simple as this. If you want to know what is minus 10 degrees Celsius in Kelvin, you just need to subtract 10 from 273 and you get 263 Kelvin. That's how simple it is, right? That's how simple it is. So Shitama, if I ask you a question, I want you to answer specifically because you're not from science background. If I ask you a question that tell me if positive 10 degree is 273 plus 10, 283 Kelvin, negative 10 degree is 273 minus 10, that is 263 Kelvin. Then tell me what will be positive 25 degrees Celsius in Kelvin. Come on, quickly. What is going to be positive 25 degrees Celsius in Kelvin? Come on. Positive 25 degrees Celsius in Kelvin. You can just write the calculation. There is no need to write the actual answer. What will that be? Don't you think it is just 273 plus 25? Right? You agree? Alright. 273 plus 25. So 273 plus 25, that will be 298. Right? How simple it is. And if I ask you, let's see, Vani, if you can answer this, although you're from science background, but we don't have Sagar today in the class. So let's suppose if you can, let's say if you can answer this, what will be minus 273 degrees Celsius in Kelvin? Vani, what would that be? Minus 273 degrees Celsius in Kelvin. Perfect. Very good. Very good. It is 0 Kelvin. Right? 0 Kelvin. Perfect. So that is the relationship between Kelvin and degree Celsius. So I hope all of you guys have been able to understand that you can easily convert degree Celsius into Kelvin. So guys, let's come back to the same same concept here. So we had all these deuterium, tritium, helium particles. Because of its greater mass, the gravitational pressure got increased, and because of greater gravitational pressure, the particles kept on coming closer and closer. They started rubbing around each other, creating a higher temperature, and the temperature reached up to 6,000 Kelvin. 6,000 Kelvin is the temperature, that is the minimal temperature required for this reaction to happen. So guys, last time, let's visualize one more time. So we had deuterium, tritium. They were placed too far initially, and they were simply mutually revolving around each other, or they were coalescing around each other. Coalescing. They were coalescing around each other. Coalescing basically means that when particles are revolving, but they are still attracted to each other. They are revolving around each other because of an attractive force. Like technically, Earth is coalescing around the sun, right? Revolving as well as attracted. Got it? So they are revolving as well as attracted. So we use the word coalescing for it. So coming back to the point. So we had the particles coming closer. So deuterium, these two particles, they were revolving around each other, right? And also being attracted. If I keep on increasing the matter, they kept on coming closer because of higher gravitational pressure. Higher gravitational pressure kept on bringing them closer. They kept on coming closer, and now they are literally touching each other. As they are touching each other, there's a lot of friction got created. Still there is pressure being applied, and the temperature is increasing. The moment when the temperature touches 6,000 Kelvin, the pressure is still there, the temperature touches 6,000 Kelvin, and what will happen now, guys? There is no other possibility other than these two deuteriums to fuse. Are you guys able to visualize? They both are going to fuse into each other with an extremely high pressure as well as temperature. In the case of nuclear fission, again guys, in the case of nuclear fission, the trigger condition was high speed neutron. But in the case of nuclear fusion, the trigger condition is high pressure and high temperature. High pressure, high temperature is the trigger condition. Guys, come on, quickly answer this. I want all of you to answer this time. In the case of nuclear fission, did I say anything related to pressure or temperature? The trigger condition was only high speed neutron. Was there any relationship between pressure and temperature of the surroundings? In nuclear fission, I'm asking. In nuclear fission, was there any relationship between temperature and pressure? Tell me. No relationship. That means nuclear fission can literally happen on all those places, irrespective of the pressure and temperature. So if you can take a fission reactor, put it in space where there is zero pressure, fission reactor can work in space as well, because it is independent of the pressure and temperature. If you take the fission reactor, put it at the bottom of the earth where there is incredibly high pressure, it can still function at the bottom of the earth. You can take it at a volcano, you can take it at the iceberg. Nothing is related to the surrounding temperature and pressure. Nuclear fission can act in all these places. Nuclear fission, it can happen in all these places. It is not dependent on pressure or temperature, right? I'll answer coalescing. Just one wait. So this is nuclear fission. So nuclear fission can literally happen anywhere on Earth, anywhere in space, independent of pressure and temperature. But when you talk about nuclear fusion does not require a high-speed neutron. It does not need a high-speed neutron. It only requires pressure and temperature. That means nuclear fusion can happen naturally only in those places where there is incredibly high pressure as well as temperature available. Only in those places it can happen. Nuclear fusion. Nuclear fusion, remember that, right? It can happen only in those places where there is extensively strong pressure and temperature acting. Only there nuclear fusion can happen. Got it, all of you? Now, what was coalescing? Vani, coalescing basically means that two bodies which are mutually revolving around each other but are also attracted to each other at the same time. So they are mutually revolving but due to an attractive force. We call them coalescing, right? Like there could be mutual revolution but they may still be repelling. Centrifugal force we call it. So that would be not coalescing. Coalescing usually works when there is a attractive force, centripetal force acting, right? So this is what we have under the trigger condition for nuclear fusion. And guys, mind my words, the temperature and pressure needs to be very high. Only then two hydrogens will fuse into one helium. Now guys, let's visualize this reaction. So you can see here the deuterium, it has one neutron, one proton, and tritium, it has one proton, two neutrons. You guys remember? So both these particles are attracted to each other, and if you apply high pressure and temperature, they both merge into each other, creating a helium. Two protons, two neutrons, and one extra neutron is released. So basically what is happening in this entire process, there were two nuclei. Both these nuclei had a little bit of strong nuclear force. They both fuse into one nucleus, and as they fuse into one nucleus, whatever extra energy that was there, it will be released in the form of nuclear fusion energy. It will be released in the form of nuclear fusion energy because two nuclei are merging into one. So when they merge into one, whatever extra energy that was there, whatever extra strong nuclear force was there, it gets released in the surroundings in the form of nuclear fusion energy. So it gets released in the form of nuclear fusion energy. Got it, all of you? Got it? Shitama, you get it? So the concept is very simple. In the case of nuclear fission, we use high speed neutron. In the case of nuclear fusion, we use high pressure, high temperature. That's it. High pressure, high temperature is the condition for nuclear fusion. Alright. But now guys, look at the temperature guys once. The temperature is 6000 Kelvin. Do you know how hot is 6000 Kelvin? How much hot is 6000 Kelvin guys? Do you have any idea about it? If I just look at the periodic table one more time, you remember the periodic table? If I just look at the periodic table one more time and I find out what is the melting point or boiling point of all the elements, you'll be surprised to know out of all the elements of the periodic table, tungsten out of all the elements of the periodic table, tungsten is one element that has got the highest melting point or boiling point out of all elements. So out of all the elements in the periodic table, the highest melting point, boiling point is of tungsten. The melting point of tungsten, at this temperature the tungsten solid tungsten melts. It is 3900 Kelvin. And the boiling point of tungsten is 5900 Kelvin. Sorry, melting point is close to 3000 Kelvin. Just 1 second guys, let me just check. Melting point of tungsten kitna hai? 3000. I think 2900 Kelvin hai, if I'm not wrong. Melting point of tungsten. Acha, 3 in Kelvin. In Kelvin, 36. Yeah, so close to. We wrote 39. It is close to 3700. All right. So let's write it 3700 Kelvin. So melting point of tungsten is 3700 Kelvin, and boiling point of tungsten is 5900 Kelvin. 5900 Kelvin is the boiling point of tungsten. That means, guys, at 6000 Kelvin, at this 6000 Kelvin, there is no substance, there is no type of matter that can really exist in its own state at 6000 Kelvin. It is so hot that nothing can really exist at 6000 Kelvin. It is so hot, guys, right? 6000 Kelvin. So the question is, how can we really create a reactor like this? See, this is a reaction that happens. This is a reaction that happens on the sun. On the sun, this reaction happens naturally. So sun has got the temperature of 6000 Kelvin. Sun has got massive gravitational pressure. So sun can easily sustain this type of temperature, this type of reaction. Even when you try to replicate this reaction on Earth, we can replicate it. We can once achieve a temperature of 6000 Kelvin and let hydrogen fuse. But once the hydrogen starts fusing, it becomes an uncontrollable reaction. So when it comes to nuclear fusion, you'll be surprised to know that for nuclear fusion, we have already achieved uncontrolled. Acha, by the way, guys, one more point. You know, the nuclear fusion reactions are also called as thermonuclear reactions. Nuclear fusion is also called as thermonuclear reactions. Why thermonuclear reactions? Because it's a nuclear reaction that happens at high temperature, right? So nuclear fusion reactions are also called thermonuclear reactions because they are nuclear reactions happening at higher temperature. So we also call them thermonuclear. So remember, guys, sometimes UPSC may not use the word nuclear fusion. Sometimes they use the word simply thermonuclear. So if they use the word thermonuclear, don't be confused. They are still talking about nuclear fusion only. So when it comes to nuclear fusion, we have already been able to create an uncontrolled thermonuclear reaction. We have already been able to achieve an uncontrolled thermonuclear reaction. And guys, this uncontrolled thermonuclear reaction is what is known as hydrogen bomb. This word hydrogen bomb is basically an uncontrolled thermonuclear reaction. So what we do in this uncontrolled thermonuclear reaction, we simply take bunch of deuterium tritium, we increase the temperature, and once the temperature and pressure gets increased, one hydrogen starts fusing, it will produce more energy and other hydrogens also start fusing, releasing an uncontrollable amount of energy. So uncontrolled thermonuclear reactions have already become a reality. Even India has also successfully demonstrated their thermonuclear bombs. In 1998, when we conducted the second nuclear test, we did a total of 5 nuclear tests, out of which 2 of them were nuclear fission bombs and 3 of them were nuclear fusion or thermonuclear bombs, right? In 1998, when India conducted their second nuclear test, we demonstrated both thermonuclear and nuclear fission bombs. But guys, the question here is, can we create a controlled thermonuclear reaction? Is it possible for us to perform a controlled thermonuclear reaction? Is it possible for us to perform a controlled thermonuclear reaction? That is the question. Is it possible for us to perform a controlled thermonuclear reaction? So guys, we all know that there are no reactor vessels, there are no reactor walls that are capable enough of maintaining their integrity at 6000 Kelvin. So the question is, the moment when we start this reaction, the temperature crosses 6000 Kelvin, the reactor will lose its integrity, the reactor will get compromised. So guys, since 1950s, by the way, let me tell you, 1945 was the year when world witnessed nuclear fission. 1945, the Trinity explosion and then bombs dropped on Hiroshima and Nagasaki. Nuclear fusion, it was first demonstrated in 1952 only. So there is not much gap between fission and fusion. First fission reactor 1945, first fusion reactor 1952, right? There is no much gap between the two technologies. But guys, what is interesting to see, that since 1952 we have not witnessed any country to successfully demonstrate controlled thermonuclear reaction. Controlled thermonuclear reaction is still a challenge. It is still a challenge for us. Are you guys able to understand up till here? Shritama, you understood? Right? So it is still a big challenge when it comes to a controlled thermonuclear reaction. But guys, what they say is that a challenge for someone is an opportunity for somebody else. Don't you think so? A challenge for somebody becomes an opportunity for somebody else. So what may be a challenge for me could be an opportunity for you, right? So there are still some courageous scientists who have taken the pledge, or you can say who have taken the initiative of performing the world's first controlled thermonuclear reaction. They are trying to control the energy that powers the sun. They are trying to control the energy that powers a hydrogen bomb. And guys, please write down the name of this initiative. It's called ITER. ITER. Please write down ITER. ITER stands for International Thermonuclear Experimental Reactor. International Thermonuclear Experimental Reactor. International Thermonuclear Experimental Reactor. ITER. Please write down. And what is this ITER, guys? What is this ITER? You can see it is the world's first attempt. It is the world's first ever attempt to demonstrate conditions for a sustained nuclear fusion reaction. World's first attempt for a sustained nuclear fusion reaction, right? And guys, this is where the next topic comes. Very important, guys. So before I go ahead and talk about ITER, before we discuss ITER, let us first try to diagnose the meaning of the word International Thermonuclear Experimental Reactor. Let's see. So guys, I always tell students that the best way to understand, the best way to figure out, the best way to understand the meaning of these processes, the meaning of these experiments, is to read the full form in reverse. Read the entire thing in reverse. So guys, what is an international thermonuclear reaction? So it is a reactor, right, which is an experiment. That means it is happening for the first time, still at experimental stage, happening for the first time. Experiment demonstrating what? Experiment demonstrating a thermonuclear reaction, that means nuclear fusion, and that too a single country would struggle. A single country would find it very difficult to actually perform a reaction at this scale. So it has turned out to be an international effort. So guys, it is an international effort to demonstrate controlled nuclear fusion reaction. It is an international effort to demonstrate a controlled nuclear fusion reaction or reactor, right? It's an international effort. And guys, when I say international effort, please do note that it's a joint effort of 35 countries. It's a joint effort involving 35 countries. 35 countries are a part of this particular initiative. That's why it's called the international initiative. And what are those 35 countries? Out of these 35 countries, 29 countries are European Union plus UK. So 28 countries from European Union plus UK. This is the first group of countries. And the second group are 6 countries outside Europe, and these countries are India. If India is there, China will also be there. If China is there, USA will also be there. If USA is there, Russia will also be there. And then guys, South Korea and Japan, right? Although if you learn a little more about world history, you will come across that Russia and Japan also have a lot of territorial disputes, right? You might have heard of Kuril Islands. Abhi recently there was an earthquake in the Kuril Islands, you might have heard, right? So this is what we have, right? So we have these: India, China, USA, Russia, South Korea, and Japan. All these 6 countries outside Europe. And guys, if you talk about the ownership, if you talk about ownership here, all these 6 countries have 9% each. The ownership is 9% each. So how much will that be? 9% of India, 9% of China, 9% of all these countries. The total comes out to be 54%. So 54% of the ownership is with these 6 countries, and rest 46% ownership is with Europe. 46% ownership of ITER is with the European Union. Now guys, remember, today UK is not part of European Union anymore. You must have heard that Britain has exited European Union, right? So UK is not a part of European Union anymore, but when this agreement was signed, that time UK was a part. So that's why I've written European Union plus UK, right? And together they own 46%. Rather, and other 6 countries, they own 9% each. So India is a 9% owner of this particular experiment. And guys, where is this reactor being set up? This reactor is being set up at, the location of this reactor is at France. It is being set up at France. And guys, the expected date of this reactor to start is in December 2025, this year. So guys, it can be the biggest scientific achievement of the year 2025, ITER. Got it? But guys, before ITER itself, chalo, I'll talk about that part later. So ITER is going to be one of the biggest scientific achievements, right? And guys, ITER is famously called as artificial sun. Why it is called an artificial sun? For an obvious reason, because we are trying to replicate sun's energy. We are trying to replicate the sun's energy, and as we are replicating the sun's energy, that's why it has famously got the name artificial sun. But guys, understand this. When we talked about nuclear fission, again, when we talk about nuclear fission, the trigger condition was high speed neutron. High speed neutron was the trigger condition, and this trigger condition of high speed neutron, you guys know, it started and created a nuclear chain reaction. And if the trigger condition was not controlled, the nuclear chain reaction would become uncontrolled nuclear chain reaction. Remember? So the entire idea of nuclear fission was to create an uncontrolled chain reaction. And how did we control the energy output? We control the energy output by controlling the trigger condition, by controlling the moving neutrons. Got it? Now, when it comes to ITER, we all know the trigger condition for thermonuclear reaction is high pressure and high temperature. This is the trigger condition for thermonuclear reaction, right? For thermonuclear reaction, this is the trigger condition, high pressure and high temperature. So guys, if you want to control this reaction and you want to contain this reaction and sustain it for a longer period, what is the method? Again, controlling the trigger condition. So here also we need to control the trigger condition. Like we control the trigger condition in nuclear fission, we'll control the trigger condition of nuclear fusion as well, right? So the concept is same, controlling the trigger condition. Got it? Got it all of you, controlling the trigger condition. Now the question is how? How are we controlling the trigger condition? So guys, let's suppose we have got the nuclear fusion reactor in front of us. We have just started the reaction. The reaction started happening, the temperature increased, the pressure increased, and hydrogen start fusing. But suddenly we realize that now this reactor can become uncontrollable. The walls are not going to protect us. The entire integrity of the reactor is going to be lost, right? So there, what we can do? In the case of nuclear fission, we could absorb the extra neutrons and reduce the energy output. But in the case of nuclear fusion, what we do, we have built the world's largest ever cooling system. The world's largest ever cooling system. And guys, I'm not exaggerating when I say largest ever cooling system, right? This is called cryostat. cryostat is the largest cooling system ever built on Earth, and cryostat is so massive that cryostat would be capable of maintaining a temperature of minus 269 degrees Celsius. It will be capable of maintaining a temperature of minus 269 degrees Celsius. And how much is minus 269 degrees Celsius in Kelvin? Just 4 Kelvin. It will be capable of maintaining a temperature of just 4 Kelvin. Now guys, let me tell you that it's not like we haven't achieved this temperature before. Scientists have successfully achieved a temperature of minus 272, minus 272.5, minus 272.9. They have achieved that kind of temperature as well. But the thing is, the temperature is achieved at a very small scale, at a scale of an atom, at a scale of a molecule, and that too for a very small duration. If this temperature needs to be attained for an entire nuclear power plant, at that scale, we have done it for the first time for cryostat. With cryostat, we have been able to create a cooling system that can maintain a temperature up to minus 269 degrees Celsius. And guys, can you take a guess which country would have developed the cryostat? Take a guess, guys. Which country do you think would have developed the cryostat? Remember, guys, this temperature is the coolest possible temperature on Earth. And just to give you a quick example, just to give you a quick reference, then you guys answer. Just to give you a quick reference that how cold is minus 269 degrees Celsius. So guys, you know what? In 2006, America, NASA, they sent a probe to Pluto. The name of that probe was New Horizons. It never landed on Pluto. It simply revolved around Pluto. It simply flew around Pluto and went right further. So it was called New Horizon. It was sent in 2006. Somewhere around 2015, it reached Pluto. And when it was flying around Pluto, it took some of its best possible images. Now this New Horizon probe also had a thermal camera, which not only took images but also tried to find out the temperature of Pluto's surface. And guys, New Horizon discovered that the temperature of Pluto, New Horizon discovered that the temperature of Pluto is minus 238 degrees Celsius. This is the temperature of Pluto, minus 238 degrees Celsius. That means when you talk about one of the farthest object of our solar system, it still maintains a temperature of minus 238. Whereas on Earth, we have built a cooling system which is going to be 30 degrees cooler than Pluto. 30 degrees cooler than Pluto, guys. That means cryostat is likely to be the coolest place in the entire solar system, guys. It will be the coolest place of the solar system, not just from Earth. It is going to be the coolest place of the entire solar system. Pluto is hotter, 30 degrees hotter than cryostat. So do you understand how incredibly cold it is? This has been the development, this has been the creation, the invention to control ITER. And now guys, take a guess which country has developed ITER? Which country has developed cryostat? The cryostat has been developed by which country? Of course, very good Shitama, it is India, right? This is the contribution that India is making. So like I said, India has 9% ownership. So we must have made a contribution in ITER, and India's major contribution is in the creation of cryostat. Actually, L&T, you must have heard of a very prestigious company of India. L&T has manufactured the components for cryostat. Actually, we have made most of the components for cryostat. Of course, the assembly is happening in France only. The components have already been delivered from India. Right, we delivered the components way back. I think somewhere around COVID or before COVID only, we delivered all the components. And now India has fulfilled its own obligation in ITER. So guys, this is what is expected to happen, and by December this year we may see a new type of energy, a new dawn of energy security would become a regular event for us in December 2025. But guys, mind my words, although ITER is going to be an important achievement for not just for the world, specifically for India, because India is a part of this initiative, but you can understand that there are many other countries who are part of the initiative. So we'll see how is the distribution, how is the intellectual property rights handled between the countries. We'll see that part now. So I hope all of you guys have been able to understand up till here. So ITER is going to be this particular achievement, and I hope all of you have understood this part. Now guys, I'll make you understand ITER further, but with the help of a question that is here. Please write down this question. Please write down this question. The approach of taking science is a little different than the approach that I used in environment, right? In science, I normally discuss things with questions only. In environment, I have taken questions later, right? So guys, please write down this question. Hydrogen is often regarded as a fuel for the future. In this context, what are the benefits of India's contribution to ITER? Guys, it's a very good question. Not because I have made it. It's a good question because UPSC have not asked a question like this so far, right? Although hydrogen based energy questions, I made this question long time back, guys, somewhere around 2016-17 I made this question, right? And now it is almost clear that everybody knows hydrogen. We are working on it. Very recently you must have seen the India's first 100% made in India or make in India green hydrogen plant opened in Kandla, Gujarat, right? So we'll see all those things. What is green, what is blue, all those types of hydrogen also we'll see. So guys, please write down, hydrogen is often regarded as a fuel for the future. In this context, what are the benefits of India's contribution to ITER, right? So guys, mind my words. When it comes to hydrogen is often regarded as a fuel for the future. When you talk about this particular point, fuel for the future, so when you answer this question, of course, this question, if it is asked, it should not be beyond 150 words, right? It is not a question that can be suitable for 250 word answer. But if it is asked for 250 words, you can still write down 250 words. But I think this question is more relevant for a 150 word answer, right? So try to write this answer in 150 words. But I'm going to discuss the entire question, so you simply have to draft or write it in your own words, okay? So guys, in this question, when you see, the first statement says hydrogen is often regarded as a fuel for the future. That means the question already acknowledges that hydrogen is considered as a fuel for the future. You only have to give validations for it, right? So you only have to present points why it is a fuel for the future, right? So first you have to mention why it is a fuel for the future. That is, you are supposed to write in the first part. In the first part of the answer, you have to simply give validations that why hydrogen is is rightly said or rightly considered as the fuel for the future. That's part number one, or first part of the answer. And then we'll talk about India's contributions to ITER and what benefits we have with this contribution. Okay, so these are going to be the two parts of the discussion. Guys, let us start with the first part. Let us start with the first part of the discussion, that is, hydrogen is regarded as a future fuel. Now guys, if I ask you a question like this, suppose if I ask you this question, that tell me what are the conditions to decide a future fuel. If I ask you this question, that suppose if I ask you what that we want to start or we want to decide a future fuel, what are the parameters that you are going to keep in your mind to fix or to decide a future fuel? What do you guys think? What parameters are you going to keep in your mind? What parameters? Tell me guys, can coal be a future fuel? Of course not, right? Coal cannot be a future fuel. Coal releases greenhouse gases like CO2. Coal releases a lot of ash, dust, air pollution. So of course, Joshua, Sherafin Joshua, you have written that it should be pollution free. All right, perfect. It should be pollution free. That's absolutely correct. Other points? Sustainability, Shafiq has mentioned. All right, good point. Sustainability basically means, again, the impact of environment on environment should be less. Very good. It should be abundantly available. It should be abundantly available, right? So its availability should be high. Then it should be energy saving. I think what you mean by this, Shritama, is it should be energy efficient, right? It should not consume a lot of energy in production compared to the energy that it provides, right? So good point again. Anybody else? Exactly, cost effective. It has to be cost effective, guys. Let me tell you one thing, guys. You know, fossil fuel today is considered as an incredible fuel, right? Fossil fuels like petrol, diesel, kerosene, coal, all these are natural gas, all these are fossil fuels. There is no doubt that fossil fuels today are considered to be a problem, right? They are considered to be causing environmental problems, air pollution, climate change, all these things. But don't you think in the last 200 years of industrialization, fossil fuels have supported the entire industrialization across the world? Whoever country, whichever country has become industrialized, they all have become industrialized after exploitation of the fossil fuels, right? At the cost of the fossil fuels. And guys, you'll be surprised to know that fossil fuels are rather extremely cheap fuels as well. They are very cheap compared to all the other alternatives. And I can tell you how cheap it is. If any one of you comes from economics, it's an actual comparison that we do in economics, comparing the cost of fossil fuel with that of the cost of Coca-Cola. I've done this experiment. Some of the students of old classes might have seen that I've often conducted this particular discussion with the students, that I often compare the cost of Coca-Cola with that of the cost of crude oil. What is the cost of Coca-Cola these days? Any one of you who has purchased a bottle of Coke? What is the cost of Coke these days, guys? How much is the cost of Coke these days? Come on. Any one of you? None of you have purchased Coca-Cola? Alright, Sharafin is saying 500 ml comes for 40 rupees. So if 500 ml comes for 40 rupees, that means the cost of 1 liter is 80 rupees, let's say. The cost of 1 liter is 80 rupees. Now, can anyone check the price of crude oil today? Can anyone check the price of crude oil today in the international market? Okay, I'll search it for you quickly. So, if I just search crude oil prices today, right? Crude oil. Crude oil is basically that oil from where you extract petrol, kerosene, right? Crude oil prices today, right? Oh, crude oil, I don't know what I have written here. Crude oil prices. Crude oil prices today. So guys, what is the crude oil rate today? So as of 8th of August, 2025, the crude oil prices is $63, 63.88. It says 63.88. All right, Sharifin, you have already calculated. You have already found out it is 63.88 per barrel. Per barrel. How much is barrel, guys? Barrel is 150 liters. Barrel is equal to 150 liters, right? So one barrel is 150 liters, and let's say it is $63 per barrel. That means, guys, if I ask you how much is 1 liter of crude oil, that means if 150 liters are $63, that means 1 liter is definitely less than half of $1, right? Is definitely less than half of $1. Now, guys, how much is the price of $1 today? I think close to 85 rupees, 85, 87. Right, 0.4. Sharafin, I have already calculated. Very good. So $0.4 is for 1 liter of crude oil. How much is the cost of $1 today? Sharafin, you have been very generous in finding all these values. Please find that also. How much is the cost of $1 today? How much is $1 costing today in terms of rupees? It is, I think 85, 87 hoga. I think I don't think it has touched 90 yet, or maybe it might have touched 90. All right, 87. So 87 rupees for $1. How much is $0.4 in rupees? Of course, it has to be somewhere around 40, right? Somewhere around 40 rupees, right? Less than 43. So somewhere around 40, 37, 38, 40 rupees. That means 40 rupees you are supposed to pay for 1 liter of crude oil. And how much was Coca-Cola? 35.03 is the cost of 1 liter of crude oil. And how much was Coke? 80 rupees a liter. 500 ml comes for 40 rupees. So 80 rupees a liter. That means Coke still in India is more expensive than 1 liter of crude oil. And guys, it is an economic fact, guys. It's an economic fact that you just search the price of Coca-Cola since 1896 it has been released. It was introduced to the world in 1896, price of Coca-Cola. and it has always been more expensive than crude oil. It's a fact, guys. It's a fact that Coca-Cola has always been more expensive than crude oil. Always been more expensive than crude oil, Coca-Cola, right? And it's an economic, it's not a theory, but it is a very interesting economic comparison between crude oil and Coke, right? So you can understand the crude oil, we may find it expensive in India because we have to pay high taxes, but otherwise the price of Coke has always been more than the price of crude oil. It is an economic fact, guys. So just imagine saying that crude oil is expensive, it is irrelevant. Crude oil is actually a very cheap source of energy. It is still a cheap source of energy and it is expected to remain like that, right? So I hope all of you got it, that crude oil is still cheap, and the reason why crude oil has fueled the industrial revolution of the past 200 years, it's mainly because of its cheap value. It is actually cheap globally, guys. It is just that taxes makes it appear to be expensive, but it is actually cheap in the market. I hope all of you get it, right? So if you talk about a future fuel, the future fuel have to be environmentally sustainable, less polluting, less greenhouse gases. All those points we can understand, abundantly available. But the criteria, the one major problem that it will face is, can it match the costing of crude oil? Because crude oil, despite of all its demerits, one advantage is that crude oil is abundant as well as it is cheaply available. You know, still majority of the crude oil is still there inside the earth, which we have not yet harnessed. Are you guys able to get it? So this is the simple concept of crude oil and Coca-Cola. I hope all of you guys must have learned something interesting in comparison today. So guys, when you talk about a future fuel, it has to be affordable, abundant, and should be sustainable, should be what all other points you made, pollution free and all those things, right? Now guys, to understand this particular answer, I have created 4 parameters. The 4 parameters are based on your answers only. So let's start. The first parameter that I have considered to decide a future fuel, I have written availability. The first parameter is availability. How easily a fuel is available. So only those substances can become a future fuel which are easily available. Right, only those substances can become a future fuel which are easily available, right? So those fuels that are easily available, they can become a future fuel, right? They can be considered as future fuels, things which are easily available. So guys, let me talk about availability of hydrogen. Guys, when it comes to hydrogen, you'll be surprised to know that 99% of the entire universe is made up of just 2 elements, hydrogen and helium. 99% of the entire universe is made up of just 2 elements, hydrogen and helium. Hydrogen and helium makes 99% of the entire universe, right? So when you compare the two, hydrogen and helium, hydrogen, it is nearly 74% and helium is 25%, right? And guys, rest all the elements that we have in our body, carbon, nitrogen, oxygen, what we have around us, it is all comprising just 1%. 99% of the entire universe is just hydrogen and helium. Hydrogen, helium occupies 99% of the entire universe, guys. Entire universe, I'm saying 99% of the entire universe is hydrogen and helium. Are you guys able to get it? Are you guys able to understand? 99% of the entire universe is made up of hydrogen as well as helium. So in terms of availability, there is no other element that is more widely available than hydrogen. In terms of availability, no other element is more widely available than hydrogen. So guys, can I say in terms of availability, check, nothing is more available than hydrogen, right? Hydrogen is undoubtedly the most abundantly available element in nature. And guys, even if you look at Earth, we know that more than 70% Earth is water. And what is water, guys? Water is H2O. And if you look at water, H2O, 66% of water is hydrogen, guys. 66% of water is hydrogen, and 70% of the earth is water, so nearly 50% of the earth is hydrogen. So hydrogen is present in 50% of the earth. And guys, I'm just comparing water with other elements. Hydrogen is found in many other forms on earth. If I just consider water of the earth, 50% of the earth is just hydrogen, right, from the water that it has. So one can easily understand that there is abundance of hydrogen across the universe. That's point number one. Then guys, the second condition of the future fuel. Please pay 100% attention, guys. The second condition that I've considered for future fuel is, condition number 2 is, its environmental impact. The environmental impact of the fuel. What is going to be the environmental impact of the fuel? First condition, availability, how easily available it is. Second is environmental impact. Now guys, if I talk about this particular fuel, if I talk about this fuel here, sorry, all of you guys know what you call this fuel? CH4 is methane. All of you know. Now you know what guys, methane is a very good fuel. There is no doubt that methane is a very good fuel. It's an incredible type of fuel, methane. But do you know why methane is a good fuel? Why methane is considered as a good fuel? The reason why methane is a good fuel is not because of the carbon that it has. Methane is a good fuel because it is 80% hydrogen. Methane is a fuel because it is 80% hydrogen and 20% carbon. Guys, just think about it. It is CH4. So 4 hydrogen, 1 carbon. Total 5 atoms are there, 1 carbon and 4 hydrogen. So 80% is the atomic weightage of hydrogen and 20% is of carbon in terms of atoms, right? 20% carbon. So you know, methane is a very good fuel, not because of the 20% carbon it has. It is a good fuel because it has 80% hydrogen. And guys, mind my words, any fuel is, see, a fuel is a substance that releases energy in burning, right? When you burn the fuel, it produces energy. The energy that is released in burning of the fuel, it is all because of the hydrogen present in the fuel. You all must have heard that we normally use the word hydrocarbon for all kinds of fuels. We normally use a word hydrocarbon. Hydrocarbon is basically a word used to identify substances that have both hydrogen and carbon. Like methane is a hydrocarbon, CH4. Similarly, just like methane, there are so many other types of examples of hydrocarbons which are also good fuel, like the LPG gas in our house. It is mostly propane and butane. Propane is nothing but propane. It is C3H8. Butane, it is C4H10. Sorry, H10. C4H10. What is it? Carbon, hydrogen, carbon, hydrogen. They all are examples of hydrocarbon, and guys, they all are considered to be good fuels, not because of the carbon but because of hydrogen. They all contain hydrogen, and it is the hydrogen that makes them a very good fuel. It is the presence of hydrogen that makes all these substances a very good fuel. Presence of hydrogen, remember that. In fact guys, we don't have to look anything beyond our own body also. When you talk about the human body, I hope all of you guys know the energy that we get from our food. The food that we are talking about is carbohydrates or typically glucose. The energy that we get in our body is from glucose. Glucose is C6H12O6. This is glucose guys, C6H12O6. If you look at the percentage of hydrogen, glucose is also nearly 50%, not nearly, exactly 50% hydrogen. So glucose gives us instant energy. It's because even this contains 50% hydrogen. So whatever energy we get from the food that we eat, it is also because of hydrogen. Are you guys able to understand? So hydrogen undoubtedly is the reason why all these fuels are considered to be good fuels. But think about it guys. So methane is a very good fuel because it contains hydrogen. But look at methane. If I burn methane, CH4, when I burn methane, CH4, I burn it in the presence of oxygen, and what it releases? It releases CO2, carbon dioxide plus water plus energy. No doubt the energy production is high because it is 80% hydrogen, but I hope all of you understand the CO2 that is produced. This is a greenhouse gas. So this carbon, the carbon of methane comes out in the form of CO2. Of course, it will also give some energy because the bond breaks, but the energy output is very less compared to hydrogen. And so carbon part of methane comes out and starts causing global warming in the form of CO2. But guys, the hydrogen part of methane releases water and energy. Water and energy. So hydrogen releases water and energy, and carbon releases CO2. So guys, if I want to talk about environmental impact of methane, methane is a good fuel, but it produces CO2, and that's why it can support global warming, it will support climate change. But imagine guys, please pay attention, imagine if we only consider hydrogen, if I only consider hydrogen as a fuel, right? If I only consider hydrogen as a fuel and burn hydrogen in the presence of oxygen, what is going to be produced? It will produce water and energy. That's it. Nothing dangerous. Only water and energy is produced. Only water and energy is produced. There is nothing that the environment will be worried of. Only water and hydrogen is produced. So guys, there is no doubt that when you talk about environmental impact of a future fuel, it has to be environmentally neutral, it has to be environmentally conducive. It should not cause any kind of damage to the environment. And when you compare it with hydrogen, hydrogen is a perfect fuel for future, even if I consider environmental impact. Tell me yes in the chat quickly guys, all of you. Tell me yes in the chat if you guys are able to understand that environmental impact of hydrogen is going to be almost negligible because it only produces water. Now guys, imagine, do the math guys, do this math. If hydrogen is produced from water itself, water contains 66% hydrogen, right? Water is made up of 66% hydrogen. So if water is used to produce hydrogen, hydrogen in burning again produces water. So don't you think it also fits into the definition of renewable fuel? We are producing hydrogen from water, and as we burn this hydrogen, it again produces water. So don't you think it also completely fits into the definition of a renewable fuel? I hope all of you guys are able to get it. This is what we have under the simple concept of environment impact, right? This is the second part. This is the second part of the discussion, right? Second. So after its availability, high availability, second is environmental impact, and environmental impact of hydrogen is almost zero, almost none environmental impact is there. Very good. Now guys, comes the third aspect of a future fuel. Third aspect, which I think is a very important aspect, and I do not have much space, so I'm going to use this space at the lower end because I want to give you in the form of annotations whatever I'm writing here. So the third aspect of a future fuel, it is, I use the word adaptability. Or I would use flexibility. Adaptability or flexibility. The meaning is how easy, how convenient it is for us to adapt with this new fuel. How convenient it is for us to adapt with this new fuel or to use this new fuel. See, just think about it. I remember the time when CNG was introduced in India. I hope you guys know CNG, compressed natural gas, right? Many vehicles in many of our cities, especially the three-wheelers, the taxis, they run on CNG, right? All of you must have seen those CNG buses, cars and autos. Now, when CNG got introduced, we learned that CNG does not require a separate engine. There is just a minor kit that is installed in a regular diesel engine, in a regular petrol engine, and the engine can become compatible with CNG. You guys know this? That for CNG, you just have to put a small kit and the vehicle becomes, bi-fuel, or it becomes two-fuel vehicle. If it is petrol, it can run on petrol and CNG. If it is diesel, it can run on diesel and CNG, right? So CNG CNG kit can be fit into both petrol and diesel vehicles. Got it, all of you? So that means it was still not difficult to adapt. So people would have to spend around 20-30,000 rupees, and their petrol diesel vehicle can easily be switched into a CNG vehicle, right? That means the technology required is easy to adapt, right? The vehicles, the same cars, you don't have to throw away your car. The car can be the same vehicle. You just have to modify it by simply putting an external kit. Got it? So that means switching with CNG, it was easy to adapt, right? It was somewhat easy to adapt. But guys, now you know that the government of India is promoting EVs, right? Government of India is promoting EVs at the same time. Now when we talk about EVs, electric vehicles, don't you think electric vehicles are somewhat difficult to adapt? When you talk about adaptation to electric vehicles, because see, when you talk about fossil fuel cars, you can refuel the vehicle as and when you find a petrol pump, you find a fuel station, you can refuel the vehicle, right? Whenever you find one. It takes hardly few minutes and the car is ready. It can run for thousands of kilometers without any major long-term stoppage. But when it comes to electric vehicles, you guys are probably aware that there is an issue of range anxiety. You cannot plan a long trip. You cannot plan a long distance trip with the EVs without planning for its charges, without planning for its chargers, availability of chargers, and whether you are taking the right road where you can find chargers available. Right? I hope all of you understand this. So when it comes to electric vehicles, the adaptation of electric vehicles is somewhat difficult because it will ask for some major lifestyle changes, right? You will have to plan your trips in such a way where you can do a lot of other activities in between your trip. And guys, I'm telling you with my own personal experience. In March 2023, one of my own friends, he bought a Nexon EV Max, right? It was the longer range Nexon car, and we thought of going from Delhi to Nainital. Normally it takes us around 5 to 6 hours to reach Nainital. This time it took us 11.5 hours, right? So you can understand, because we had to keep charging the car somewhere in between. We had to take detours to find a charger, and that's how it took us a very long time. And one single charge, if we do not find a high speed charger, it would take around at least 1 hour, 1.5 hour of waiting, right? So those kind of wait would become really excruciating. So you can understand that kind of anxiety is there. So adapting to EVs is somewhat difficult when it comes to your petrol compared to the petrol vehicles, right? Until we have a very large scale infrastructure of EV or charging infrastructure, then it's a different case altogether, right? All of you understand? Now let's talk about hydrogen. Adapting to hydrogen, will it be a problematic thing or not? So guys, before I talk about hydrogen and its flexibility, let me ask you a question here. If I ask you, what is the fuel that we use in your internal combustion vehicles? Petrol, diesel, CNG, these are the fuels used, right? Now tell me guys, can petrol, diesel, CNG be used for running? See, we are burning these fuels and we are producing energy and we are releasing that energy, and that's how the car or your vehicles run, right? We burn the fuel, petrol, diesel and CNG. Tell me guys, can petrol, diesel, CNG be used for making electric cells or electric batteries or battery EVs? No, it cannot be a fuel for EVs, right? Because EVs run on a different technology. Do you know what is the battery technology which is more popular today? Most popular batteries are made up of which material? What is the fuel that we use? Very good, lithium ion batteries. Acha, by the way, there is a new type of battery that has come into the market. It has already been introduced for small EVs and mobile phones. It's called silicon carbon batteries, right? It's silicone, C-O-N-E, not silicon, right? I'll talk about silicon carbon batteries in the discussion of energy technology, right? So we'll talk about that. So UPSC can ask in the prelims exam regarding silicon carbon batteries. They are considered to be better than lithium, although they are technically lithium ion batteries only, but they use silicone as one of the electrodes, right? So basically the idea is that, so guys, before I go ahead, when you talk about, can anyone tell me the difference between an engine and a cell Can anyone tell me the difference between an engine and a cell? Engine और cell के बीच का कोई difference बताएगा? Can anyone tell me the difference between an engine and a cell? Guys, let me answer this quickly because it's already 9 o'clock. I want to finish one more topic after this. So engine basically are those systems which burn fuel and convert the heat of the fuel, heat energy, into some kind of mechanical energy. So engines simply produces heat and they convert the heat into some mechanical energy. So engine produces heat, right? So engine works by the principle of heat. They burn the fuel and use the heat of the fuel to produce energy, some other form of energy. What is a cell, guys? A cell is something that produces energy in the form of electricity. So engine produces energy in the form of heat, cell produces energy in the form of electricity. As simple as this. Of course, there are different types of cells. There could be some cells that are called storage cells. Some cells are called rechargeable cells. Different types of cells are there. But remember, every cell produces electricity. Whenever the word cell comes, and whatever cell it could be, remember all the cells produces electricity. That's it. All engines will only produce heat. That's it, right? Acha, what is a battery, guys? A battery is nothing but a plural of cells. You know, it's been raining since last night in Delhi. It's been raining quite heavily in Delhi, right? So what is a battery? A battery is plural of a cell, right? Plural of a cell, right? So combination of multiple cells, it's called a battery. That's it, right? So a cell is something that produces electricity. Engine is something that produces heat. That's it. Now guys, what is the fuel that we use for engines? Petrol, diesel, CNG. Can it be used in a cell? No. What is the fuel that we use in a cell? Lithium. Can it be used in an engine? No. Lithium engines cannot be made. Although lithium can burn in the presence of oxygen, but it cannot produce energy like petrol, diesel or CNG. So lithium is a fuel that is used only for making cells. Petrol, diesel, CNG is the fuel that can be used only for making engines. But guys, when you talk about hydrogen, hydrogen is the only fuel right now. It is the only fuel right now which, if you want, you can use it as a fuel in engines, or if you want, you can use it as a fuel for cells. There are already hydrogen powered engines. We call them, I'm writing it here, cryogenic engines. The cryogenic engines are running on hydrogen. Then guys, apart from this, we also have hydrogen internal combustion engines. We call them HICE, hydrogen internal combustion engine. That is also a reality. And guys, when you talk about hydrogen cells, there is already a cell known as hydrogen fuel cell. Hydrogen fuel cell, which is a cell producing or using hydrogen producing electricity. So guys, can there be a fuel which is better adaptable than this? You just produce hydrogen once and then you can choose for yourself which type of fuel source you want. If you want to produce electricity, you use it in a hydrogen fuel cell. If you want to produce heat, you use it in a cryogenic engine or in a hydrogen internal combustion engine. And guys, one more thing, we have just now learned that hydrogen is also a fuel for a nuclear reactor. ITER. ITER is running on hydrogen, deuterium and tritium. So guys, there is no other fuel in the universe which have been found to be more adaptive than hydrogen. So when it comes to hydrogen as a future fuel, in terms of adaptation and flexibility, check. No other fuel is more adaptable and flexible than hydrogen. You produce hydrogen just once. So guys, here India need not have to worry how we are going to use hydrogen. You just produce hydrogen. You can use it as an engine. The engine technology is already there. You can use it in a cell. The cell battery technology is also there. Hydrogen fuel cell. And if you want, once the ITER gets ready, you have the ITER also available. You can use it as a future energy source for thermonuclear power. Are you guys able to understand? This is what makes hydrogen a very possible contender for future fuel. Got it, all of you? And now guys, the fourth parameter. The fourth parameter for the future fuel, it is costing. I'm writing it here. Fourth parameter, it is cost, or you can say affordability. How easy it is to afford. And guys, this is where hydrogen loses. When you talk about crude oil, like as just now we have done a simple calculation that 1 liter of crude oil is costing less than half a dollar. I think Sharafin, you found out it was somewhere close to $0.35, right? $0.35 you found. So it is less than half a dollar. That is the cost of crude oil. Guys, when you talk about hydrogen, 1 kilogram of hydrogen is around $4 to $5. $4 to $5 for 1 kilogram of hydrogen, right? And you know why the cost of hydrogen is high? Actually, guys, production of hydrogen is not difficult. In fact, I can also demonstrate you how to produce hydrogen in the class itself. I just need a beaker of water, 2 pencil lead and a battery, and I can easily demonstrate in the class itself that how easy it is to produce hydrogen. It can easily be produced, guys. We will talk about a method called electrolysis of water, right, in the topic of energy technology. So producing hydrogen is easy, but the biggest problem of hydrogen is the smallest atom in nature, guys. It is the smallest atom, just 1 proton, 1 neutron, 1 electron. In fact, neutron is not there in most of the cases. So just 1 proton, 1 electron. It is so small, it is such a small element that hydrogen, it cannot be stored anywhere. Like say for example, if this particular tube, if this particular bottle would have been a steel bottle, then guys, steel, it otherwise is very robust, it is otherwise very strong, but you know, steel is nowhere capable of storing hydrogen, because even if you look at steel from a microscope, it may have small void spaces, it may have tiny spaces in between the molecules, in between the atoms, which may be big enough for hydrogen to pass through. So the problem with hydrogen is its storage is very expensive. And guys, normally if you look at the pressure, at which your gas cylinder comes, if you just search the pressure for your CNG or your gas cylinders, it is around 120 psi. The pressure of your LPG cylinder, it is around 120 psi. LPG is a heavy gas, right? So LPG cylinder pressure. So LPG cylinder pressure in psi, it is 120, I believe. Yes, look at this. 100 to 200. What does it say? 100 to 200 psi. 100 to 200 psi is the pressure that you need in an LPG cylinder. So all of you have seen those red color LPG cylinders that are delivered to our house. Nowadays we have got connections, CNG or LNG connections, but still you guys may be able to recall that there was a time when LPG cylinders were there. The pressure that they have is 100 to 200 psi. When I compare this with hydrogen, hydrogen required 350 to 400. In fact, would be more than that, right? 350, right? Look at this. The hydrogen pressure is around, look at this. Oh, sorry, psi mein 5000 to 10,000, right? In bar it is 350 bar. It is 5000 to 10,000 psi, right? So you can just imagine that the pressure gradient which is required, it is 1000 times more than LPG cylinder. So the problem of hydrogen is that it has to be stored at a very high pressure, right? It has to be stored at a highly compressed form at a very high pressure. Only then you can store hydrogen. So guys, hydrogen is expensive not because of its extraction. It is expensive because of its storage and transportation. Its storage and transportation is very expensive, right? Storage and transportation is quite expensive, hydrogen. Are you guys able to understand? So when it comes to hydrogen, its production cost is almost negligible, right? Because it is produced from water, right? The storage cost is very high. So it is the storage of hydrogen that go up to 5000 psi. What I read was originally 350 psi, but 350 bar it is. I think I might have mistaken the unit there, right? So 5000 psi. So one can easily understand that how difficult it would be to store hydrogen. So guys, this is the challenge that we have in terms of storage of hydrogen. And guys, again I would tell you the same thing. if you talk about all the other factors that make hydrogen a future fuel, there is no doubt that hydrogen in terms of availability is very high. There is no other fuel that matches hydrogen. In terms of environmental impact, it is probably the best fuel. No other fuel again matches hydrogen. In terms of its adaptability and flexibility, there is no other fuel that matches hydrogen. So when you have these three advantages, don't you think countries which should invest more and more in R&D so that we can find cheaper ways of storing hydrogen? So if we can crack, just guys think about it, if India can crack this particular problem of storage of hydrogen, if we can find a cheaper way of storing hydrogen, maybe through nanotechnology can develop new kinds of materials, if you can find an affordable way of storing hydrogen, then don't you think India can become the next, global hub of future energy supplies? Future energy supplies. And guys, this is what India has also planned. You'll be surprised to know in the year 2020, in the year 2020, Government of India launched National Hydrogen Mission, or also known as National Green Hydrogen Mission. The objective of this National Hydrogen Mission is to reduce the cost of hydrogen to $2 a kg. To reduce the cost of hydrogen to $2 a kg. To reduce it to $2. So right now it is around $4 to $5. If we can reduce the cost of hydrogen to $2 a kilo, then it can be a very big achievement, and India can become a net exporter of this technology. But guys, remember, India is not alone. We are not alone in this particular fight. You know what? Mr. Jeff Bezos, have you heard of him before? Mr. Jeff Bezos, the owner of Amazon. Mr. Jeff Bezos in 2018 itself announced that he'll be spending around 1 billion US dollars. 1 billion US dollars, almost 8500 crores. He would be spending on future hydrogen research, and his objective is to reduce the cost of hydrogen to $1 a kilo. $1 a kilo, right? Just to equal to $1. In fact, Mr. Mukesh Ambani, he has also announced, Mr. Mukesh Ambani also have a lot of money, so he has also made a similar announcement that he will also work and reduce the cost of hydrogen to $1 a kg by 2030. And guys, remember, right now Reliance is the largest hydrogen producer in the country as of now, right? So are you guys able to understand in terms of future fuels? I hope there is no one who has having problem or any doubts that hydrogen cannot be a future fuel. It has all the capability of being a future fuel. The only challenge is its storage. But mind my words, guys, it is not a small challenge, right? Because you are trying to store the smallest particle or the smallest atom in the universe, right? So it will not be easy to store that easily. So this is where the countries have to work. So remember, guys, anything that is a challenge is an opportunity for us, right? Is an opportunity. So if there is a challenge that the cost of hydrogen is high because of high storage and transportation, it can be an opportunity for finding a way and becoming the next global hub of energy supplies. Got it, all of you? So this was the first part of the discussion of this answer. Now guys, the second part of the discussion is India's contribution to ITER. Now this I want you guys to write. Please write down how ITER is helping India, right? Or what India is going to benefit, right, from ITER, from its participation to ITER. So point number one, first point, write down under this particular point. Write down the first point. It will introduce a new type of energy source that can last for millions of years. It's a fact, guys, because hydrogen is the most abundant element. So if ITER becomes a reality, ITER can literally work for millions of years, because hydrogen is the most abundantly available element in the universe, right? So it can create a source of energy which can last for millions of years. Hydrogen, right? I hope you guys are able to get it. That's point number one. Second point for ITER. So it can provide energy for millions of years. Then second is, so guys, just to elaborate on this point, if you ask me what is the cost of ITER, so you know what, all the countries together have invested around 20 billion US dollars to make ITER. Now 20 billion US dollar is a very big amount. It is close to 170 lakh crores. 170 lakh crores, 20 billion US dollar. So it's a very large amount. 170 lakh crores means we could have easily revamped all the entire power sector of India, right? But the cost of one ITER is 20 billion US dollars. Of course, this price is too high. The price is too high for energy source. But imagine if this source lasts for millions of years. Like if you talk about a thermal power plant, it lasts hardly for 30 to 50 years, right? If you talk about nuclear power plant, again 50 years. But if there is an ITER like project that can work for 1000 years, then don't you think over a period of 1000 years the cost will now appear to be cheaper, because the reactor, even if it is costing 20 billion US dollars, but it will be working for thousands of years. So that's how the cost can be made more effective, right, in long term. So this is the first part, right? It will introduce an energy source that can last for millions of years. Second point, the plants, the nuclear power plants will not produce, the nuclear power plant will not produce any harmful nuclear radiations, or you can say the nuclear power plant will produce easily controllable nuclear waste. The nuclear power plants are going to produce easily controllable nuclear waste. They will produce easily controllable nuclear waste. That means, guys, whatever nuclear waste comes out, it is going to be easily controllable, because you can understand deuterium and tritium is used as a fuel in nuclear fusion. Deuterium is not radioactive. Tritium is radioactive, but it is very weakly radioactive compared to all other large radioactive elements, right? So whatever nuclear waste is going to be produced, it will be easily controllable. Got it? So it will not have any risk of nuclear disasters also in future, right? Then, guys, third point, so easily controllable nuclear waste. Third point is it can support India's climate change commitments, right? So guys, India has already made a commitment globally that we will reduce our greenhouse gases. And it is not just India. Many countries globally have stated that they will reduce their greenhouse gas emissions, right? You might have heard, those of you who have taken ecology already, they may be knowing Paris Agreement. India has announced NDC 1, NDC 2, right? NDC 3 we are likely to announce this year in the month of November, December, right? So this is what the world has made commitments. So in the case of ITER, no dangerous waste is going to be produced, no greenhouse gases are going to be released. So it will only produce helium and water, no greenhouse gases. So you can just write down, no harmful residue is produced. Only helium and water is released as the residue. Only helium and water is released as the residue, right? And a very little bit of radiation, guys, that can also be managed easily. Only helium and water is released as the residue, and no dangerous or severe, residue. Okay, no harmful residues. So guys, these are the 4 points that one can easily understand. Got it? All of you guys can understand. Now I'll tell you some of the interesting points which are directly favoring the economics for India. Guys, have you heard of something called intellectual property rights? Have you heard of intellectual property rights? Like, say for example, if I have invented this particular stylus, I have put up my hard work, my labor, my entire creativity, right? So when I design this particular stylus, it will become my own intellectual property. But guys, I have to get the intellectual property registered. So when I get it registered with the local patent office, I will get rights, and those rights are going to be exclusive creators' rights, which will give me the power to decide how much price I want to keep for this particular stylus. If I want somebody else to manufacture it, then at what price I want him to manufacture, what is going to be the royalty sharing, everything I can decide. So these are called intellectual property rights. When it comes to ITER, there are 35 countries who have partnership in ITER. But what is the intellectual property right distribution? Guys, all countries get 100% intellectual property rights of ITER. So please write down, India gets 100% IPR, intellectual property rights of ITER. And guys, with this 100% IPR benefit, the direct advantage that we see, the direct advantage that we have here is that we can easily identify that India, once the ITER starts functioning, we don't have to take anyone's permission. We don't have to go to any country. We can simply use the entire theory of the ITER and replicate it in India and start manufacturing future thermonuclear reactors. Are you guys able to understand? So this is what we have. And guys, based on the knowledge that we have learned in ITER so far, we have already got a plasma, a reactor at Gandhinagar. It's a small prototype reactor at Indian Institute of Plasma Research in Gandhinagar, Gujarat, right? So this is already there. So one can easily understand that when it comes to the aspects of intellectual property rights, India need not have to worry about any international restrictions or regime, because India have 100% IPR. So guys, we only have to wait for the ITER to start functioning. Once ITER develops and starts functioning, we can replicate ITER in India and start producing green energy for the future. I hope all of you guys are able to understand. And then guys, if you want, you can write down points like it has helped India in creating cryostat, which is the the largest cooling system on earth, and all those things, right? But these are the important points that I've given you. And this completes our discussion on ITER as well as hydrogen as a future fuel. Please write down yes in the chat, so that I believe all of you guys have been able to understand. Please write down yes in the chat quickly. Shritama, you have understood. Sharafin, you have understood, right? What about Achintanya, Manoj and Vani? What do you guys think? Very good, Vani. So all of you guys, I believe, have been able to get it. So this is what we have under this particular question, and completes our discussion on ITER as well. Now guys, I will be going to see one more time the three. Acha guys, please wait, we have 10 minutes. Let's not see this particular discussion right now. Let us see the application of nuclear energy, because it will take some less time to finish, right? So guys, I have mentioned applications of nuclear technology. So now guys, under nuclear technology, we have learned that nuclear technology can be used to make nuclear power plants, both fission, fusion, we have understood, and it can also be used to make nuclear weapon systems, both fission and fusion, we have understood. But can there be other civilian applications of nuclear energy? Yes, there are a lot of civilian applications of nuclear energy that are possible. Let us talk about them. So guys, the first application that I want to talk about is nuclear agriculture. I want to talk about nuclear agriculture first, because we have 10-15 minutes right now, or whatever extension we'll do for another 15 minutes, we'll be able to finish this part. So guys, nuclear agriculture, this is the first application of nuclear energy, right? What is this nuclear agriculture? What exactly do we understand by nuclear agriculture? Please pay 100% attention. So guys, when we talk about genetically modified plants, we all know. Acha, before we talk about genetically modified plants, do you guys know the meaning of the word gene? What is the meaning of the word gene, guys? What exactly do we understand by the word gene? Can anyone answer? What exactly do we understand by the word gene? What exactly is a gene? Come on, quickly. A gene. See, a gene is nothing but a fragment of the DNA. So DNA is carrying all our genetic characters. When you take a certain fragment of the DNA that carries a specific character, we call it a gene. Like you guys must have heard, like some people are really tall, right? We often say that they have tall genes. So they have those sets of the DNA which happen to produce proteins that can secrete more growth hormone, right? They are naturally tall. Some people, even they do not go to the gym, but they are still very muscular. They are muscular even when they do not go to a gym, right? That means they have those genes which produce more myoglobin protein. Myoglobin is the muscle protein, right? Some people, they eat a lot, but they are still very thin, right? That means these are those people who have high myostatin protein. Myostatin protein is the protein that causes muscle depletion. So they never develop a lot of muscle, right? So basically we have different genes, and all the genes carries our different characters, right? Now guys, there are some genes which are also sometimes considered to be undesirable. Like for example, there are genes sometimes which may have a characteristic that may make a plant vulnerable to fungal infections. Like there could be some genes which may cause fungal infections in the plant, especially in the monsoon season, right? So fungus may happen to grow in some plants because they contain certain genes that produces certain proteins that helps the fungus to survive, and fungus normally causes deterioration of the plant quality and the overall yield gets damaged. Then guys, there are some genes which produces certain chemicals due to which plants or other animals may not eat them, right? Or humans may not be eating them, right? There are sometimes genes that produce some kind of neurotoxins which can cause some kind of brain damage or nervous system damage to the body. Like there was a particular variety of pulses, I don't know if you guys have heard, in Bihar and UP it is called kesari dal, right? It looks very similar to the tur dal or very similar to what is called the arhar dal, right? But it produces some neurotoxins, right? So government of India had banned this particular kesari dal. Now it has been allowed because we have made new varieties to which has less neurotoxins. So guys, there are always desirable or undesired genes that may be found in various organisms, right? There are always some genes which may be desired and some genes which may be undesired, right? And guys, we have already learned this, that when it comes to the concept of genes are basically part of your DNA and they carry a certain character. So guys, when it comes to certain plants, like for example rice is a certain plant that requires a lot of water, standing water. What if we can modify the genes of rice in such a way so that the overall water requirements of rice may be reduced and make it more resilient to droughts? Similarly, if you talk about wheat requires cooler temperature. What if we modify the genes of the wheat in such a way so that it can survive in also a little warmer temperature, does not attract any fungus, and becomes immune to fungal attacks even in summers? So don't you think it can help us in improving our food security? So guys, what has happened here, there is an organization called BARC, Bhabha Atomic Research Center. What they did, they used controlled gamma ray mutations. They used controlled gamma ray mutation. We all know that mutation basically means change in DNA. Mutation means change in the DNA or change in the genes, right? And this particular change, we all have learned that gamma rays have the tendency of penetrating deep into the cells and can change the DNA. So what Bhabha Atomic Research Center did, they studied the entire DNA profile of different plants. They took almost 42 different plants. 42 plants they have studied, and they created the entire DNA profile of the plants, studied each and every genetic code or each and every gene, and found out how many undesired genes are there in those plants. Like guys, there is one plant which they have been able to modify successfully, and that too to a very high extent, that is groundnuts. And they found that in groundnuts there are certain genes which happens to promote fungal growth. So what they did, they identified those genes that attract fungus, and with the help of gamma rays, they simply fired gamma rays onto those genetics, onto those DNAs, and altered those DNAs. And they altered in such a way so that, but remember, it is all controlled. It is not uncontrollable alteration. Controlled alteration of DNA they did, and this how they created 42 different plant seeds. We call them trombe seeds. Remember the word trombe seeds, and under trombe seeds the most popular is TG01. It is called trombe groundnut 01. This is a genetically this is not called modified, we call it genetically edited, because we have not added any new genes. We have not added any new genes, we have simply suppressed. So we often call them knockout organisms. See, when you talk about knockout organisms, we call them, like, there are two terms. One is called transgenic organism and the other one is knockout organism. What is transgenic? I'll explain this first. A transgenic organism is typically what is known as genetically modified organism. Like, you must have heard of BT cotton. BT cotton is a transgenic organism. It is actually cotton which has been modified by addition of an external gene from BT, Bacillus thuringiensis. It's a bacteria. So what they did in BT cotton, it's a plant which is a combination of two different genes from unrelated organisms. Unrelated organisms की genes हैं. So we have taken the natural cotton plant and added an external gene of BT, Bacillus thuringiensis. That is called transgenic or genetically modified. Now this would truly be a genetically modified organism because it has genes of some unrelated organism introduced. When you talk about gene edited or genetically GE organisms, genetically edited organisms, these editing organisms are usually those which has not introduced any foreign or unrelated gene. They may introduce genes from a similar species or subspecies. Let's say, for example, if there is a variety of wheat that can grow in warm conditions, and if there is a variety of wheat that grows in cold conditions. So for India, as global warming is occurring, we have to grow those kind of wheats which are more adaptable to hot conditions, warm conditions. So what India will do, they will try to gather the genes of the warm conditions and try to put those genes which makes the wheat more heat resilient, drought resilient, and they will introduce those genes in the Indian variety. So that is called gene edited. You guys may be knowing that few months back India released gene edited rice, right? It was basically a combination of genes of rice plants mixed together, which is why it is not considered as a threat, because it does not contain a foreign gene of a different organism. It contains genes of rice only, right? So here it is considered to be much more safer, right? So we have only been able to take those genes which are desirable. Now guys, what Bark has done here, they have created knockout organisms. Knockout organisms are those where undesired genes are silenced, right? So with the help of controlled gamma ray mutation, they have been able to silence the undesired genes. Guys, there is already a technique called DNA or gene silencing. We'll talk about that thing in the topic of biology, but I hope you guys have got an idea what exactly is a knockout organism. So we take the undesired genes and we try to silence them so that they do not express their characters, and in this way they were able to create a groundnut seed that was completely immune to any kind of fungal attacks. So its shelf life is longer, it can remain on the shelf for longer period, and even if the farmer has not been able to harvest it on time, there will be no crop failure as well. Are you guys able to understand? Please tell me yes in the chat. So this is one application that how. So remember, Trombe seeds is an example that you should write here, right? So Bhabha Atomic Research Center, they have been able to successfully create Trombe seeds, which happens to be, highly beneficial, in terms of controlling crop failure, right? I hope you get it. But they have done it for 42 different seeds, but out of the 42 seeds, Trombe groundnut 01, because it's obvious guys, Maharashtra is the largest producer of groundnuts. Maharashtra, Gujarat, they produce a lot of groundnuts. Groundnut seed oil is very popular there, so they have tested that kind of crop first, right? Remember, Bark is also located in Trombe, close to Mumbai only, right? This is first, nuclear agriculture. Then guys, the second aspect of nuclear energy or application of nuclear energy is food security. Guys, I would say food security, not food safety, right? Although you can consider both safety and security here, right? How it can help. Now guys, this is where I would like to talk about something which I read in 2015 economic survey. Actually, my last attempt was in 2015 only. 2015 was my last attempt. So 2015 economic survey was also the last survey that I read, right? It was the last survey that I read fully, right? It's not like I did not read any economic survey after that. Of course, for science and environment, I've been reading economic surveys. So The last complete economic survey that I read, as a student was 2015. And guys, I remember one interesting fact from that survey report. And the fact was, in India, every year, 1,70,000 crores worth of food is wasted. 1,70,000 crores worth of food is wasted every year in India. 1,70,000 crores. You know what, guys? If you look at the worth of Mr. Mukesh Ambani, around the year 2015, Mr. Mukesh Ambani's worth was also 1,70,000 crores. That means we were literally wasting one Mukesh Ambani every year. Now, why am I creating this analogy between Mukesh Ambani and food wastage? Guys, just think about the kind of resource Mr. Mukesh Ambani creates. Reliance is one of the largest multinational corporates of India. Reliance give employments to more than 6 lakh people. And imagine if 6 lakh people are earning because of Reliance. And I'm not even considering Jio. Jio might have given separate 1 lakh people, I don't know. Right? Reliance give employment to 6 lakh people. Suppose if these 6 lakh people are earning hands, single earning hands of their families. Usually in a family we have 4 people. So 4 people, 6 lakh. That means 6 lakh into 4, 24 lakh consumers are created or are dependent only on Reliance. 24 lakh consumers. And just imagine, guys, to support these 24 lakh consumers, we can build massive cities, industries, to support 24 lakh consumers. So just imagine a single company like Reliance can actually be transformed into a mega city which can have 24 lakh consumers working on Reliance, dependent on Reliance, and there would be an entire economy of other services that will be helping in their well-being. Like they would require hospitals for 24 lakh people. Just imagine how many hospitals would be built. So a separate economy will be created like that. There would be amusement parks, shopping malls, markets, everything would be required. Schools, everything. So an entire large-scale city can be built by just one company's Reliance. And guys, this much of resource India was wasting every year. You can imagine what a big wastage we were doing every year by this much of food wastage. 1,70,000. Guys, sadly, the government of India has of course taken cognizance of this wastage. They have done something about it, but still, according to the 2021 or maybe 2022 survey, the food wastage in India is still close to 1 lakh crores. Right? Still it is. So there is a huge scope. Still. So guys, BARC has again done something to reduce it, right? To reduce food wastage. Actually, when it comes to food wastage, there are multiple reasons why there is food wastage. See, the first reason is the storage cost is quite high. Let's say for example, if I am a farmer and I have cultivated, let's suppose, some vegetables or some fruits. Right? Now you guys know that MSP does not come for vegetables and fruits. Right? MSP comes only for grains. The grains that can be stored in a godown, that can be stored easily. So you get MSP for rice, wheat, you get for sugarcane, you get FRP, fair price index, right? So FPI, fair price index, and all those things. So we have, no MSP for fruits and vegetables. These are supposed to be called as perishable items, so they cannot be stored for very long. So normally for fruits and vegetables, you have to depend on the market forces. So if the market has a high demand and less supply, the price will increase. Like you have seen, sometimes the price of tomatoes increase like anything, price of onion increase like anything. It is mainly because none of them are regulated under MSP. They completely depend on the availability, demand and supply. Because tomato is 80% water, so there is a higher chance that tomato can rot easily. So either you keep it in a cold storage for a longer period so that it can remain preserved, or if you keep it in the open, the environment will destroy the quality of tomato very soon. So there is always a chance that tomato may easily, being a perishable item, its price and demand can easily change. So guys, what happens? Let's suppose I am a farmer and I've done some agriculture. I've produced some kinds of vegetables. Now what I do, I take these vegetables to the nearest mandi, to the nearest APMC and all those agriculture produce market corporations, and I go there and I try to sell them at some desirable price. But I realize that everybody else have cultivated the same crop, the same food item. So that means there is bigger supply. The demand is constant, but supply is now increased. And because of increase in supply, the price in the mandi will crash, right? Because the demand is constant and supply is more, the price will crash because there is no MSP. Now, when the price crashes, I would start thinking that, okay, right now I'm not getting some good price. Let me go and store all my produce in a cold storage. And you know what, guys? A cold storage, you know how much it charges? In a cold storage, if you want to store your entire food crop for one season, it charges around 8,000 to 18,000 rupees a ton. Rupees a ton, I'm saying. So let's suppose if I have produced one entire truckload of food, that will be around 15 tons, and I park it, I dump it in a cold storage, I will have to pay 15 into 10,000, 1,50,000 to the cold storage owner if I want to take it out after the season ends. So what I've done, guys, I've stocked my entire produce. Now, guys, tell me, when it comes to agriculture in India, do you think that kind of price fluctuation may be created ever in India, where I go to the market today, I do not get a good price, I stack it for the next 3 months or 2 months, and I assume that after 2 months the price will increase so much that I would be able to get a decent profit, and I would also be able to repay the cold storage owner 1.5 lakh. Do you think that is ever possible in India? Tell me yes or no. Can that kind of price fluctuation be created at the mandi level, where I can get a decent profit after stacking it for 2-3 months and then also pay for the cold storage amount? What do you guys think? What is your opinion? Tell me yes or no. Of course, it's very, very unreal for India to see that kind of price fluctuation. So, guys, what farmers end up doing in this situation, when they do not get a good price in the mandi and they know that cold storage is too expensive to keep, what these farmers will do? They will simply take the entire crop and dump it anywhere. Sometimes they don't even harvest it from the field. They will simply get a tractor, run the tractor over the entire crop, thinking that the crop will decompose and they will get ready for the next yield. Are you guys able to understand? This is how maximum food wastage in India occurs. So, guys, this is important. Then that's the reason why, Niti Aayog also suggested to create cold chain. Cold chain was basically a network of more and more cold storages, so that there is competition created and the price can also be regulated, so that more and more food crops gets stored in the cold chain rather than being dumped. Are you guys able to understand? Promoting food processing industry can also be helpful in storing the food for a longer period. Like pickles is one way you can store the same food for one entire year. I hope all of you guys are able to get it. This is what we have under the simple problem of food storage in the country. Now, guys, Bhabha Atomic Research Center, they have come up with a technique called food irradiation technique. Food irradiation technique. This is a technique that they have used for improving the shelf life of our food. And let me give you an example how it works. And I think this will be our last discussion. Tomorrow when we meet, we'll finish the other things tomorrow, because it's already 9:43. So guys, when you talk about food storage, we know that we put food in cold storage or refrigerators, because refrigerators reduce the temperature, and because of the reduction in temperature, bacteria and fungi, they don't grow, right? You know that if you keep the food in the open, the warm and humid weather will help bacteria and fungi to grow, and the food gets wasted. But if you store it in a refrigerator, the food will not be wasted, because the temperature does not allow bacteria to multiply. The cooler temperature do not allow bacteria to multiply. You guys must have heard of this process called pasteurization of milk. Louis Pasteur, who was a French biologist, he basically invented the process of pasteurization, where you heat the milk to 70 degrees Celsius. At 70 degrees Celsius, all viruses, all bacteria dies, and then you quickly chill it. You quickly put it in a refrigerator, so that there is no new multiplication of bacteria. That's a simple way of pasteurization. I hope all of you guys are able to understand this. So this is a simple concept of pasteurization, where we kill the bacteria and put it in some kind of environment where new bacteria cannot grow, and that's how you can increase the shelf life. So guys, today we can easily increase the shelf life of milk up to 3 to 4 days. It's only because of pasteurization. So you must have seen every time when you buy a milk packet, it says pasteurized milk, right? Because it has underwent the process of pasteurization, right? Now, what Bark has done, Bark, the same organization, has created a new technique called food irradiation technology. What they did in this, suppose whatever food you cultivate, you go to the Bark centers and they will throw some low intensity X-rays. The low intensity X-rays are going to kill all the bacterias. They will kill all the bacteria on the surface. So they will simply throw or expose the food with some low intensity X-rays, and once the X-rays have killed all the bacterias, then rather than putting them in a refrigeration system which is expensive, Bark suggests that you wrap your food in some antibacterial coating, right? Like you must have seen Tetra packs. Our milk also comes in Tetra packs, fruit juices comes in Tetra packs. Tetra packs are nothing but those antibacterial layers. They are basically made up of 4 layers. That's why the word tetra is used. 4 layers are there, and those packs are antibacterial layering. That means bacteria, fungi, no microorganism can pass through them. They are so strong and so rigid in terms of protecting. So Bark also suggests that once you irradiate the food, now there is no bacteria in the food. You just have to now wrap it in some antibacterial coating, and once you have wrapped it in an antibacterial coating, now you can keep it even at room temperature. You can stack the food even at room temperature, because now no more bacteria will attack, because it is completely protected from outside and inside there is no bacteria. So you can actually keep your food at the room temperature and still the quality of food will not go bad. Food irradiation therapy. Please write down this food irradiation technique. Write down. It refers to exposing the food with a small dose of X-rays, exposing the food with a small dose of X-rays to decontaminate, small dose of X-rays to decontaminate the entire food, and then quickly covering it with an antimicrobial coating, right? This can reduce the cost of food storage, because you can store it even at room temperature. And guys, you'll be surprised to know that FSSAI, food first FPI, right? That is, what is the full form of FPI? Food processing. What is the full form of FPI? FPI godowns. What is the full form? Food process. FSSAI, Food Safety and Standard Authority of India, and FPI, both of them have certified the safety standards of food irradiation therapy, food irradiation technique. They have already been certified, and guys, there are already 40 food irradiation centers in the country, right? Food irradiation centers in the country. So this is, sorry guys, it is not FPI, FCI, Food Corporation of India, not FPI. FCI is something else, right? Food Corporation of India, right? This is where it maintains a network of cold chains and also godowns. This is the main procuring organization for MSP products and such. So both FCI and FSSAI have approved, right, the safety standards of food irradiation technique. And guys, with this we complete the discussion of how nuclear energy can help in food storage. Are you guys able to understand? So by having a combination of cold chain and food irradiation technique, we can help the farmers store their food at a cheaper price. I hope all of you get it right. So this is what we have in today's class. We'll meet tomorrow. Tomorrow again we'll have a class, Sunday, because after tomorrow I'm giving a break. We are going on a break for one entire week, right? So after tomorrow we'll be meeting exactly next Monday. That will be 18th of August, right? And then we'll continue in one go, right? The reason why I'm taking a break, the reason why the institution is taking a break is basically so that we are expecting some more admissions. There are a lot of students we have inquiries for them, but they haven't been able to follow. So because we want some more admissions, so that you guys can also share if you find the lectures informative, so that we can have some substantial numbers, and then we'll again restart from 18th. But from 18th we'll surely be completing the entire discussion in one go, right? So guys, this is everything for in today's class. Tomorrow when we meet, we'll start from the impacts or the application of nuclear technology in water safety, healthcare, and what is astrobiology. All right guys, so that's everything for today. We'll be meeting tomorrow again at 7:30, right? Do come prepared. Tomorrow also the class may get extended, because I would be talking about some important terminologies and working of a nuclear power plant. In any case, I'll try to finish up till that particular discussion in tomorrow's class itself. All right, so that is everything for today. All the best guys. Thank you.
Thank you, sir.
Yeah, thank you.